Okay, we're going to be looking at proportional reasoning, and we're going to be using the method of constant of proportionality. The overall expectation is to solve problems involving proportional reasoning, and our specific expectation is to solve problems involving ratios, rates, and directly proportional relationships in various contexts. And this example will be constant of proportionality. So we take a look at our word problem here. The first thing we're going to do is read through the word problem once and what the question is asking us, and then we'll go through it a second time and highlight what's important. So the table below shows the cost of water for 3 different customers. They each pay the same cost per liter, and here's our table below. Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. Okay, so we'll read through this again and highlight what's important. The table below shows the cost of water for 3 different customers. Okay, so we have our 3 different customers. They each pay the same cost per liter. Okay, so we know their rate is the same. This is the table below, and we'll call this customer 1, customer 2, customer 3. Okay, and we know they're all paying the same rate. And the question asks, Gabriel pays $46 for water, so that's important. Determine the number of liters of water that he purchased. Okay, so since they want us to solve the number of liters of water that he purchased, let's extend our table here a little bit longer. So we have our table, and under dollars, we know that Gabriel has spent $46. Okay, what we're trying to find, the unknown here, is the number of liters of water that he purchased. So to use a constant of proportionality, we're going to do it 3 different ways. Each of these customers, customer 1, 2, and 3, all pay the same cost per liter as Gabriel has. So our next step will be to figure out what constant of proportionality, so what value will increase the costs, okay, of any of the customers, so let's say from customer 1 to what Gabriel paid. So we're going to look for some factor. We're going to look for an increasing relationship, that being the constant of proportionality. We're going to multiply by some number to get, for instance, customer 1's cost to the $46 that Gabriel paid. So we'll do this one set at a time, and we'll do it with all 3 customers so that you can see the relationship. What we need to find out is what number would we multiply $9.20 by. Okay, what would we multiply by to get to $46, okay? And we'll call this variable, actually we won't call it x because the multiplication sign looks so very similar to it. We'll call this variable a in this case, okay? So I'm going to set this up as an equation. This will be for customer number 1, the equation. We have $9.20 times a, so we write it as 920 or 9.2 a, is equal to the $46, okay? Now in order to isolate for a, we need to divide 9.2 or $9.20 on both sides. On the left side, it will reduce the a value to an a value of just 1. Now a lot of times they call this canceling out, but really what it is 1 times a, which is the value of a. And we need to figure out what this number is. This number will tell us what we need to multiply, okay? What we need to multiply by. So we'll take our 46 divided by 9.2. And the answer is 5. Great. So our a value is 5. So what that's telling us is if we take the amount of liters, okay, we'll do it in red, that customer 1 bought, that's the 10,000 liters, and we multiply it by the a value, which we just discovered is 5, we'll figure out how many liters Gabriel much have purchased, okay? So you might need a calculator, but this is actually a pretty straightforward calculation. 10,000 times 5 is the value of 50,000, okay? And that's it. That's technically the answer. What I'm going to do next is I'm going to show you how we could have done it with any of the customers since they were all paying the same rate. So the next thing I'm going to do, and I'm going to work down towards the bottom here, we're going to take the second customer, customer number 2. Remember, his was 18.4. Okay, so we need to find a value to multiply by, and we'll call that b. We're going to set up the same equation we had before. We know that $18.40 times our b is our constant of proportionality, is equal to the $46 Gabriel paid. So, as we said before, we got to divide both sides by 18
$2.40. Now, a lot of times what they'll say is we're kind of moving this to the other side. And because it's multiplication on this side, we divide on the right side of the equation. It's still the same idea as we talked about in the first one. It's just another way to describe it. So when you do that, you're left with b on the left side, and we got to figure out what this value is. Okay, so we take our 46 and divide it by our $18.40. It gives us a value of 2.5. So b is 2.5. So our constant of proportionality, okay, our constant of proportionality is 2.5. So let's see that. Remember, customer 2 bought 20,000 liters. So remember, this was our customer 2. Because they bought 20,000 liters, okay, we know we have to multiply by 2.5. So we're going to take 20,000 and multiply it by 2.5, and that's how many liters Gabriel should have. And it turns out that when we do that, okay, so 2.5, whoops, here we go, 2.5 multiplied by 20,000 is equal to 50,000. So exact same answer we had found before. Worked out great. Finally, our third customer. Now, this one's a little trickier. It's still the very same idea. We need to figure out, and we'll call this constant of proportionality, the C value. We need to figure out 27.6 times C equals a 46. What is our constant of proportionality? So, customer 3, $27.60 times C is equal to 46. So what we're doing is the same thing over and over and over again. We already know that this value here, the coefficient in front of the C, that's what we have to divide our constant on the other side by. So instead of moving everything over, I'm just going to put it straight into our calculator. So you've already seen this process twice. 46 divided by 27.6. Now look at this. We get a number, and on our calculator, we've even rounded it to the 1, 2, 3, 4, 5, 6, 7, 8. Looks like the 8th or 9th decimal place they've rounded to. So the C value is 1.66, and they've looks like they got about 6 sixes, and then finally rounded to a 7. But it's really a repeating decimal of 6. This is important here, okay? What that means is we need to multiply that by the 1.6 repeated to figure out how many liters. Because customer C had 30,000 liters, okay? We need to multiply it by that repeating 6 to figure out how many liters Gabriel had purchased for $46. We already know the answer is 50,000. I want to do a little experiment with you just to show you how rounding can really affect our answers. Here I'm going to take the exact value, well, the round to the 9th decimal place, and multiply it by the 30,000. And look at that. It's pretty much 50,000. 1, 2, 3, 4, and 5 decimal places in. They have a value of 1. If we were round to the whole number, we get our 50,000. Worked out great. But let's say 30,000, and let's say we rounded to 2 decimal places, 1.67. Instead of keeping this very long decimal here, what would we get? Would we get 50,000 again? Well, let's test it. 1.67 times 50,000. And did I use the right numbers there? Oh, sorry, not 50,000. 1.67 times 30,000. That's good. We made a mistake, but we corrected it. We knew that answer wasn't quite close to what Gabriel had gotten in liters. And look at that. 50,100. This value would not be correct, okay? Because we rounded too early, we got an incorrect value, okay? So we have to be very careful about our rounding. So there's our constant proportionality. We've done it using all 3 different customers. Really, we could have just been finished at customer 1, but I want to show you all 3 ways about doing this. If you want to look at other ways to solve this same question, you can check out our other playlists on proportional reasoning.